So this is the 2014 Junior Cert Higher Level Paper 1. We're looking at question number 2. John thinks that he has a method for finding all prime numbers. He says that if he uses the formulas in the table below, he will generate the prime numbers. He also says that these formulas will generate only the prime numbers. Okay, so part 1 says complete the table. Okay, so the first two are done for us. So we're given p-values down here, and then 6p plus 1 is this column, and 6p plus 5 is this column. So we're just plugging these values into these p-values into the expressions here. So this first one would be 6 bracket 1 plus 1, and that gives us 7. Then we have 6 bracket 2 plus 1, which gives us 13. 6 bracket 3 plus 1 gives us 19. 6 bracket 4 plus 1 gives us 25. 6 bracket 5 plus 1 gives us 31. And then over to this column here, where the function is 6p plus 5. So we have 6 1s plus 5, giving us 11. 6 times 2 plus 5 gives us 17. 6 times 3 plus 5 gives us 23. 6 times 4 plus 5 gives us 29. And finally 6 times 5 plus 5 gives us 35. So that's the table filled in. Part 2 says give 2 reasons why his method is not fully correct. So 2 reasons why his method is not fully correct. So his method being that he was trying to find all prime numbers and only prime numbers. So we can see from this that there's a few numbers in here that aren't prime. So 25 would be one. Prime number has only factors of itself and 1, but 25 has factors of 5 times 5 as well as 25 times 1. So 25 and 35, they're not prime. All the other numbers are. So that's one reason. 25 and 35 are not prime. Another reason would be 1 also is not prime, the number 1 that was given to us. But another reason would be it didn't produce the prime number 2, or indeed the prime number 3 either. So that's another reason. So actually it's 1, 25 and 35 are not prime. And the other reason would be that numbers 2 and 3 are not generated. They're prime. So there's our 2 reasons. Part B. The Swiss mathematician and physicist Euler first noticed in 1772 that the expression n squared minus n plus 41 gives a prime number for all positive integer values of n less than 41. Explain why it does not give a prime number for n equal to 41. Okay, so we're going to substitute n equals 41. We're going to substitute 41 in for n to the expression. So if the expression was n squared minus n plus 41, we're told that n is equal to 41. And replacing n with 41, we get 41 squared minus 41 plus 41. Now that is equal to 41 squared, because minus 41 and plus 41 here, they can combine to give 0, so you're just left with 41 squared, and 41 squared is not prime, as it has a factor of 41 itself, because 41 times 41 is 41 squared. So that's the end of part B and question 2.